.NET 9 comes with a new exciting hybrid cache library. This video will explore what, why, and how we can leverage this, and also the limitations of current approaches. Currently, in .NET we have two options for caching, iMemory cache and iDistributed cache. Here you can see an implementation of iMemory cache. Though in-memory cache or in-process cache is lightning fast, it has its limitations. It uses object reference, it's not scalable, restart of server, purge the cached data, and no stampede protection. The solution is a distributed cache like Redis. Initially, I planned to create another implementation of iCache and check if there is any distributed cache like Redis available. That implementation will be used. Otherwise, memory cache will be used. The problem with that approach was that wasn't really a multi-level cache. Alongside lacking multi-level caching, it has its own pitfalls too, like manual serialization and deserialization, and there is also no stampede protection. Hybrid cache aims to solve these problems by combining iMemory cache and iDistributed cache. It offers unified API, configurable serializers, and stampede protection. First, it tries to get data from the primary cache. If not found, it tries to connect to the secondary cache if configured. And if concurrent requests try to hit the same empty cache entry, it internally handles only the first call to the factory method to repopulate the cache and await others. Here is an example of memory cache. Here you can see a C# record named post with user ID created at body and request count properties. Then a GraphQL API named cache test. We can think of it as a minimal API endpoint that uses iMemory cache as dependency. This uses iMemory cache's get or create method. The get or create method takes a key and a factory method to populate the data if a cache miss. In this case, the factory method is get from DB simulation. After running the application, we landed on GraphQL Nitro, an inbuilt GraphQL client like Postman. Here we have a query section, response section, and response log section. GraphQL is a very broad topic and not in the context of this video. If you want to know more about it, let me know in the comments below. After running the query to execute the API we saw earlier, we can see the response. The response has a created on field, which is the exact time of creating the object, and a request count, which is a static integer field that denotes how many times the DB operation occurred. In this response log section, we can see the execution time of the query. As we can see, the first request takes a little bit of time, but subsequent requests are fast. Drastic reduction of execution time, all thanks to caching. By default, the hybrid cache uses in-memory cache for primary cache storage. Since this is a GraphQL application, I can run a query multiple times and see the logs. Now, let's replicate the query 3 times and execute it to simulate 3 concurrent requests. After running the query, we can see request count increases for every response object and different times for every created on property. This shows us the factory method executes multiple times, though we have cache in place. This is cache stampede. Concurrent requests try to repopulate missed cache entry. So, let's start solving our problems with hybrid caching. First, we need to install a new package named microsoft.extensions.caching.hybrid. At the moment of recording this video, this package is still in its pre-release version. Make sure to check pre-release. To use this library, we need to inject it. Now let's refactor our previous implementation with shiny new hybrid caching. Just replace iMemory cache dependency with hybrid cache, and IDE suggests passing the cancellation token. Let's do it. After running once again, the application and the query, the cache stampede problem is already resolved. As we can see in the response, request count is 1 in all objects and all objects have the same created at date. Let's add Redis as a second level cache. Now let's run the application. By browsing the Redis cache server, we can see that our second level cache is also being used without any explicit configuration with hybrid cache. Now let's remove the test codes and use the hybrid cache in a real world scenario. In my application, I am using a repository with cache aside pattern. First, I am removing the iCache service since we no longer need this and replacing this with hybrid cache and refactoring accordingly. And we hit the first problem of the hybrid cache. This library doesn't have any key checker functionality like the Stack Exchange Redis library has. This might be because it is currently in preview. For the time being, I am assuming after updating the entry might be requested again to show. So I am setting this in the cache and running the application. I have prepared a query that will use the repository I just refactored. After running, we hit another problem of hybrid cache, which says deserialization of types without a parameterless constructor, a singular parameterized constructor, or a parameterized constructor annotated with JSON constructor attribute is not supported, and some type information afterwards. It means whatever object hybrid cache tries to create does not have a public constructor to use. If we go to the class, we can see there is no public constructor or default constructor or constructor with JSON constructor attribute, and every property has a private setter. So the error is legitimate. Since the hybrid cache uses system.text.json, it cannot deserialize to this class's object. One way to solve this is providing the JSON constructor attribute to constructor and JSON include attribute to properties. As you can see, adding attribute to every property and every constructor of every class and record we will cache is a little bit cumbersome and hard to enforce. Another way to solve this, we can use hybrid cache's pluggable custom serializer feature. To do this, after adding the hybrid cache, I will change the call to add serializer factory with cache serializer factory as a type parameter. This is a custom factory class I wrote to provide a serializer on the fly to hybrid cache using newtonsoft.json. This class implements hybrid cache's iSerializer factory interface, and we need to implement the try create serializer method with a type parameter. This method will return an instance of the serializer class, which must implement the iHybridCache serializer interface. I created the custom JSON serializer class. Let's rename this class with newtonsoft.json serializer. I implemented deserialize and serialize methods. Here I just used newtonsoft.json libraries, serialization and deserialization functionality in place of system.text.json functionality and provided a JSON settings with a value of contract resolver as private setter contract resolver and constructor handling as non-public default constructor. Here are the private setter contract resolver is also a custom tailored class to access private setters since we saw that all properties have private setters in my class. Finally, we have to add a default private constructor to our class. Those who are familiar with Entity Framework, you know that it also needs a default constructor if every setter is private. It doesn't care if it is private or public or internal. Let's run our application once again. Clear the console and previous request logs and we run the query. As you can see, our query executes successfully with values as we expected and uses both levels of cache. So, by implementing a hybrid cache, we got a multi-level cache out of the box, mitigated a stampede problem, and made our application's caching scalable. So, in this video, we explored .NET 9's hybrid caching, what problem it solves, and its configurations. If you found this video helpful, please like, subscribe, turn on notifications, and share it with your peers. Thanks for watching, happy coding, and see you in the next video.